This is the continuance of Chapter 9.1 lecture. This is part 2. Let's go ahead and now actually create a confidence interval. And again, a confidence interval is just an estimate for the population, but instead of giving a single value, we say the estimate is from some lower bound to some upper bound. How old are you, Professor Romero? Give me an estimate. You can say between 40 and 60. That would be an interval estimate. And so we do that in statistics. We'll use this example to do that. In order to do that, we will use StatCrunch, but I do expect for this section that you will do some of this by hand. You can use StatCrunch to definitely check your answers, but there will be some expectation that you would do some of these formulas by hand. They look complicated, but we've already done these formulas, so hopefully they're not too scary. And so example 2, constructing the confidence interval, looking at this over here. So looking at example 2. In July of 2008, there was a university poll asked 1,783 registered voters whether they favored or opposed the death penalty. 1,123 were in favor. Obtain a 90% confidence interval for the proportion of registered voters nationwide who are in favor of the death penalty for persons convicted of murder. And so in this case here, okay, what are we going to do? Well, a confidence interval again is a point estimate plus or minus margin of error. And so to get the lower bound, this value is going to be your point estimate minus your margin of error. And we're going to call that E. E, this is E, your margin of error. And then to get your upper value of your estimate, it's going to be the estimate plus E. So all we need to do is calculate those. And so looking at the formulas over here, lower bound is P hat plus this here. This value here, all of that is E, which is your margin of error. Let's put that in blue since I was matching that up. That's E, your margin of error. And this here is your margin of error. And so all you need to then worry about to get your margin of error, your lower bound and upper bound, is to actually calculate these values. And so you can see down here, right here is your E, what I was talking about. Here's the formula for your margin of error. And in these cases, remember, we want a 90% confidence interval. And so that has an alpha level 0.10. So I could say obtain a 90% confidence interval, or I can say obtain a confidence interval with an alpha of 0.10. I can say either way. Okay. Alpha, again, is kind of what our error part, what we're our percent that we could be wrong with our estimate. And so to get these values, to get our error here, we need P. To get our confidence, we need P hat. We need and E. And to get E, we need these values here. So this Z, which we did in a previous, is what's called a critical value. That's a critical value. And so we need that. This here is your standard error from 8.2. And then that would equal your margin of error. And that's all we need to do. Once we have that, then we add that or subtract that from the P hat. In this case here, our P hat for this problem is going to be equal to 1123 divided by 783. And so that's our P hat for this problem here. 1123 divided by 1783, 0.6298, or approximately 0.630 is what we would have there. To get a confidence interval, I'm trying to find an estimate. So right now, about 63% of the people favor the death penalty, but that's just an estimate, a single point. We want some interval to be 90% confident with our answer. And so we need a critical value. Where does that come? That's a z value. Z alpha over 2. What's alpha in this case? That's 0.10. I got that from over here. Let me put that in red. That's 0.10 because of 90%. The leftover, our percent error, is 10%. Alpha over 2 is then, in this case, we want a critical value of 0.05. We had done this in a homework assignment previously, getting a critical value of 0.05. There's two ways to do that. One way is to, so I need a critical value. This is what probably the hardest part of finding a confidence interval is a critical value, and it's not that hard. All you need to do is you go to StatCrunch, calculator, normal, and what you do is you put 0.005 here, change to greater than, compute, and there is your critical value, 1.64. 1.64 is your critical value there. There's another way to get critical value. We have some standard values that we use in confidence intervals that are given to you. If you're given the most common confidence intervals, it's called the critical value right here. This is from the book. And here are, if you have a 90% confidence interval, here is your critical value, 1.645. And then you can use this. I have to show you, but again, that comes directly from what we have here, 1.645. So that's your critical value that you would use in the calculation of the error. And so the critical value for this problem is 1.645. What's the standard error? It's the square root of p hat, 0.630 times 1 minus that. 1 minus 0.630 is going to be 0.370. All of that divided by n. N in this case was 1783. And so we would have to calculate that value. 0.630 0.01143, and then the margin of error is going to be equal to 1.645. You can do this in one step. I just broke it down this time, but you could do this in one step if you wanted to, and then multiply that. And so I get a margin of error 0.0188. And so what's going to be your lower bound and upper bound? You're going to go here. Lower bound is going to be 0.630 plus, sorry, not a plus. Lower bound would be minus 0.0188. Upper bound is 0.630 plus 0.0188. And so you get those answers there. So you have 0.6488. And then your lower bound is going to be 0.611. 0.6112. And so then we have a confidence interval. Confidence interval is 0.6112 to 0.6488. That's what we would use. It's an interval notation. And so the important part comes here, the interpretation of this. So what is this going to mean? This is how we're going to say it. What do these values mean? We are 90% confident. We are 90% confident that the proportion of voters right here who favor the voters who favor the death penalty, the confident that the proportion of voters who favor the death penalty is between 61.12% and 64.8%. So that's how we're going to say it. We are 90% confident that the proportion of voters who favor the death penalty is between 61 and 64%, or 61.12 and 64.88%. That's an interval estimate. We're estimating how many people favor the death penalty in the population. Our original estimate is more likely wrong, of 63, so we devise a method to calculate an interval. I'm going to show you from StatCrunch what the answer from StatCrunch is, which is a highly accurate answer because they're not surrounding. You will see the lower limit, upper limit, sample proportion. You can see that where we get that from. And you have your upper and lower limit. Where that would come from, let's show you now one time. You would go to Stat, in this case proportion stats, one sample with, we don't have the data, we have the summary. And so the number of successes was 1123 out of 1783. We are constructing a 90% confidence interval, leave it as standard walled, and that's it. Hit compute. And when you do that, you end up with the confidence interval. Notice you end up with your standard error. You end up with your proportion. The standard error is that square root. You would still have to multiply that by the critical value, and then that gives you these values. So there's our first example of constructing a confidence interval, and then our interpretation, which I'm going to remind you here.